Apache Spark is one of the best frameworks to handle large data and perform analysis. It is widely used in industry for two main reasons: in-memory computation and parallel processing. There is an important concept that serves as the foundation of Apache Spark termed as RDD. In fact, it is often known as backbone of Apache Spark. So with these interesting facts, let's move forward to know more about PySpark RDD. Hi everyone, I'm Umra Suhail. Welcome to Simplilearn's YouTube channel. In this session, we will explore PySpark RDD. If you want more amazing tech-related videos, do like and subscribe and hit the bell icon to stay tuned. So before moving forward, let's have a quick look at agenda. We will begin the session by discussing why exactly we need PySpark RDD and what are PySpark RDD, then the various features of RDD, along with the operations that can be performed. Next, I will show you guys some demo related to transformation and action, and then the pair RDD operation in PySpark. After that, we will have a look at transformation and action in pair RDD. Let's get to the video to learn more about PySpark RDD without any further delay. So before, many of the frameworks were facing challenges in processing multiple tasks like Hadoop, a stable intermediate data store that was required to HDFS and Amazon S3. By using these media, the execution of numerous computation was performed, including logistic regression, PageRank algorithm, k-means, etc. Sharing data involves several input-output operations such as replication and serialization. It leads to slow data processing. Therefore, there was a demand for anything that could solve the issue of solving input-output operations while resolving the problem of high memory drain. Then their RDD came into the picture. So with this, let's look at our next topic, that is what is PySpark RDD. Resilient Distributed Dataset, often known as RDD, are the components used in a cluster parallel processing that run and operate across several nodes. Since RDDs are immutable elements, you cannot alter them after creation. Because RDDs are fault-tolerant, they will immediately recover from any failure. Now let's have a look at each of its features. Coming to features of RDD, the first is in-memory, then lazy evolution, then immutable, persistence, partition, parallel, fault tolerance, location sickness. In memory, Spark RDD can be used to store data. Data storage in a Spark RDD is size and volume independent. We can save any size or amount of data. The term in-memory computation refers to processing data stored in the main RAM. Operating across tasks is necessary, not in intricate databases, because running databases slow the drives. Lazy evolution. Its name implies that the execution process does not begin immediately after calling a certain operation. There must be an action taken to start the execution. As a result of such action, RDD data cannot be transformed or made public. Spark keeps track of each operation performed through DAG, referring to a directed acyclic graph or DAG. Immutable. Since RDDs cannot be changed over time, they are immutable. When we carry out more computation, that property helps to maintain consistency. RDDs that have already been generated cannot be changed. They can only be turned into new RDDs. This is made feasible by its process of transformation. Persistence. All data can be kept on disk memory and processed in storage. Additionally, we can retrieve it straight from memory. Because of this, RDD are advantageous for quick computation. As a result, we can run several operations on the same dataset. This leads to reusability as well, which speeds up the computation. Partition. Each dataset is logically divided into smaller chunks and dispersed among cluster nodes. They are not inherently divided. They are just partitioned to improve processing. This partition configuration offers parallelism. So coming to parallel, RDDs are logically divided across cluster. As we covered earlier, when we do any operations, the complete set of data is run concurrently. Coming to fault tolerance, if we lose any RDD while working on any node, the RDD will automatically recover. Different transformation that we apply to RDD result in a logical execution strategy. The term lineage graph often refers to logical execution plan. As a result, if a machine malfunction occurs, we could lose RDD. We can therefore retrieve the same dataset by performing the same computation on that of the lineage graph. And actually, this practice strengthened its fault tolerance ability. Location sickness. RDD support placement preferences. This is information on RDD's location that the computational partition are places using the DAG, Directed Acyclic Graph Scheduler. To manage tasks effectively, DAG helps keep them as near the data as possible. The placement of the data speeds up the computation as well. RDDs allow you to do a various operation to complete a certain goal. So with this, let's look at the operation with PySpark RDD. A fundamental data structure in PySpark is the Resilient Distributed Dataset or RDD, a low-level object. PySpark RDDs are very effective at handling distributed jobs. Any task can be completed using a collection of operations in PySpark RDD. These processes fall into two categories: data transformation and action. Let's learn about transformation first. Transformation are a kind of operation that accepts an RDD as input and output another RDD. A transform RDD returns a new RDD. The old RDD remain unchanged and immutable. The transformation generates a directed acyclic graph or DAG for computation after applying it and stops after performing any operations. So with this, let's look at few of PySpark RDD fundamental transformation right away. The first is the map transformation, filter transformation, union transformation, flat map transformation. So with this, let's look at the actions in PySpark RDD. So with this, let's look at actions in PySpark RDD. In PySpark RDDs, actions are a kind of operation that returns a value on being applied to an RDD. So following are some of the essential PySpark RDD operation widely used, that are collect action, count action, take action, first action, reduce action, and save action. So with this, let's get to our next topic, that is PySpark pair RDD operations. For pair RDDs, PySpark offers a specific set of operations. Pair RDD are a unique class of data structure in PySpark that take the form of key-value pairs, hence the name, because most real-world data is in the form of key or value pairs. Pair RDD are practically employed more frequently. The term key and value are used differently by pair RDDs. The value is referred to as data, whereas the key is referred to as an identifier. So with this, we have come to our next topic, that is transformation in pair RDD. We must utilize operations that use keys and values since pair RDDs are built from many tuples. So following are the widely used transformations on a pair RDD, starting from the reduce by key, sort by key, group by key. So with this, let's get to the action in PySpark pair RDD. Despite the fact that pair RDDs can be used for any RDD action, there are a few articles that are tailored exclusively for pair RDDs. These actions should be used with the pair RDDs and will not function on regular RDDs. With PySpark pair RDD, action is having only one function, that is count by key. The number of value associated with each key in the provided data is counted by the count by key action. So now with this, let's get to the demo section. Transformation and action in PySpark RDD demo. Now let's open the Google Colab. So now go to File, open a new notebook. With this, you can see the new notebook is coming on the screen. So basically for practice purposes, all the following operation will be carried out in Google Colab. Various conditions must be completed on our PC before we can do PySpark RDD operations. You can adhere to the following requirements while practicing on your personal computer. So you just have to get to the code and write pip install PySpark. Let's run it. Now as you can see on the screen, it's installed. Next, we will initialize a Spark context to perform the operation. Let's get to the code and from PySpark import Spark context. Let's run it. And please consult the PySpark installation guide for local machines if you are unable to complete the prerequisites for any of the following reasons. Now that we have Spark context ready with us, we can carry out all the upcoming transformation and actions. So let's go. Let's get to the code. Here we will see the example of map transformation. Let's run the code. Here we use the Spark context parallelize method to construct an RDD called myRDD. We utilize the collect action to extract every resultant element from a Python list because the map action is a transformation and returns a new RDD. So the anomalous function for lambda operates similarly in this case to how it operates in Python. So here we get the output 26, 34, 42 and 50. Yeah. So next is filter transformation. Let's look at its example. Let's get to the code and understand the example of the filter transformation. Let's run the program. Using the parallelize method of Spark context, we first construct an RDD in our case called f underscore RDD. The even number from our RDD, f underscore RDD, were then removed using the anomalous function of lambda. We use the collect operation to retrieve every resultant element in a list because the filter transformation returns a RDD. So with this, let's come to our next function, that is the union transformation. Let's have an example to understand it better. Here, let's get to the code and take an example of union transformation. Let's run it. Here we used Spark context parallelize method to first establish an RDD called input. Then using the filter dot method on the input RDD, we produced two additional RDDs, u underscore RDD1 and u underscore RDD2. Finally, we use the dot union transformation to generate the union of two filter RDDs. So with this, let's look at the next function, that is flap map transformation. So let's get to the code and see the flat map transformation example. Let's run it. Here we first use the parallelize method to build an RDD called fmap underscore RDD, and then we added two strings to it. Then we transform it with the flat map function to separate all the strings into individual words. Similar to Python list.split technique, this has the same effect. Then we extracted every resultant element in a list using the collect method. And the output is hello world, welcome to the PySpark RDD. Basically, in PySpark RDDs, actions are a kind of operations that return a value on being applied to an RDD. So with this, let's look the action in PySpark RDD. So I'm going to show you some examples of actions in PySpark RDD. Let's go. So this is an example of collect action. Let's get to the code and write the example of collect action. Let's run it. Basically, here we started by utilizing the parallelize method of Spark context to construct an RDD called collect underscore RDD. The collect method, which returns a list of all the elements from collect RDD, was then used on our RDD. And so the output on our screen, as you can see, that is 15, 24, 33, 42 and 51. So with this, let's look at the other operation, that is the count action. Let's get to the code and write the example of count action. Let's run this. Here we started by utilizing the parallelize method of Spark context to construct an RDD called collect underscore RDD. The number of entries in our RDD were determined by applying the count method to it. And the output is 9. As you can see, we learn about the functions in PySpark RDD in actions. So our next operation is the take action. To the code, we will see the example of take action also. So let's run it. And here we started by utilizing the parallelize method of Spark context to construct an RDD called tk underscore RDD, as you can see on the screen. Then we used our RDD to take RDD to apply the take3 function. This caused the RDD to return a list for 3 elements. As you can see, the outputs are 3 elements: 23, 67, 71. So with this, we have come to our next operation, that is the reduce action. Let's get to the code. As you can see on the screen, here is the example of reduce action. Let's run it. Here we use the Spark context parallelize method to construct an RDD called RDD underscore RDD. We used a lambda or enclosed anonymous function with the reduce method on read underscore RDD, as you can see on the screen. In this case, the lambda prints after adding each element in the supplied RDD. And as you can see, the output is 90. Let's get to the code. And our next operation is the save action. Let's take an example of save action and run it. Here we use the Spark context parallelize method to build an RDD called sv underscore RDD. As you can see on the screen, we saved it on our direct using the .save as text file method on sv underscore RDD with the same name supplied as an argument in it as a string type. With the specified argument, the .save as text file function creates a directory. Depending on the file size, different parts of the file will be produced inside the directory. So with this, we have come to the end of PySpark pair operations. Now we will look at the example of PySpark pair RDD operations. Now have a look at the demo of transformation and action in PySpark pair RDD. As we have seen the examples of transformation and action of PySpark RDD. And now we will see the examples of transformation and action in PySpark pair RDD. So let's get to the code. And our first operation is the reduce by key transformation. Let's take an example. As you can see, the example is here on the screen. Let's run this. Here also, using Spark context parallelize method, we built an RDD called mks underscore RDD and inserted a list of tuple containing student mark, as you can see on the screen. Then using an anonymous method enclosed within the reduce by key transformation, we performed the group by key transformation to the mks RDD dataset. The collect action was used to create the list of the resultant element because the action creates a new RDD. As you can see on the screen, the output are Amelia 81, Mary 69, Gomez 90, Jesse 61 and Frank 94. With this, let's look at our second operation, that is the sort by key. Let's get to the code and take an example of sort by key. Let's run this. Using Spark context parallelize method, we built an RDD called mks underscore RDD, as you can see on the screen, and inserted a list of tuples containing a student marks. On this RDD, we use the sort by key transformation. In order to sort the keys in ascending order, we also gave the string arguments ascending to the sort by key transformation, as you can see on the screen. Finally, we obtained a list of all the result elements by calling the collect method on the returned RDD, as you can see on the screen. The output is Jesse 38, Frank 49, Amelia 43, Mary 33, Go 48, Jesse 23, Frank 45, Jane 38, Mary 36. Our next transformation is the group by key transformation. So let's take an example of group by key transformation so we can understand it better. Let's get to the code and write the example of group by key transformation. Let's run it and see. On executing, we are getting Amelia 43, 38, Mary 33, 36, Gomes 48, 42, Jesse 38, 23, Frank 49 and 45. As you can see on the screen, using Spark context parallelize method, we built an RDD called mks underscore RDD and inserted a list of tuples containing student marks. Then we transformed the core RDD using the group by operation. The results were then saved to the DCT underscore RDD after being obtained to using the collect method. We use the for loop on DCT underscore RDD, a dictionary type item, to obtain a list of grades for each student in each line. Since students can receive more than one topic mark, we also added list to the values. So with this, we have come to the end of transformation in pair RDD. So now let's have a look at actions in pair RDD. Actions in pair RDD only have a one operation. Let's perform that, and that is the count by key. Let's take an example of count by key. Let's perform it. As you can see, on executing this code, we get Jesse 2, Frank 2, Amelia 2, Mary 1, and Gomes 1. And as usual, using Spark's context parallelize method, we built an RDD called MKS_RDD and inserted a list of containing student marks. This dictionary is written by the count by key operation. We save the dictionary entries in the variable DCT_RDD. Later, after repeating these steps, we obtain the total number of values associated with each key. So with this, we have come to the end of the session on PySpark RDD. I hope you found the session both interesting and exciting. If you have any questions about any of the topic covered in this session, or if you need the resources used in this session, please let us know in the comment section below. And our team of experts will be pleased to respond as soon as possible. Thank you until next time. This is Umra from Simplilearn team signing off. Continue to learn and stay safe.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.